Algebra 2, Lesson 9, we're going to talk about multiplying matrices. We've talked about adding and subtracting matrices, right? What a matrix is, it's just a different way of showing data. We usually show it in with dimensions, which give me rows by columns and that type of thing. So today we're going to talk about multiplying sets of data or multiplying matrices. So matrix A can be multiplied by another matrix, but only if the number of columns of matrix A matches the same number as the number of rows in matrix B. All right, so the inside numbers, that's the last number of the dimensions of matrix A and the first number of the dimensions of matrix B. They have to be the same. Okay, so just looking at this first part here, if I have a 2 by 2 matrix, I can multiply that by a 2 by 2 matrix B. Or even if this was, let's say if I change this to a, I can change this to a 2 by 8, and I can still multiply those two matrices. It doesn't, the part that matters is, does the columns from matrix A match the rows in matrix B? And if that's the case, I can multiply them. Now, multiplication is not commutative at this point, okay? Just because I can multiply matrix A by matrix B doesn't mean I can multiply matrix B by matrix A. Here's the reason why, is that if I switch these two and I move B over to the left and A over to the right, then I have a 2 here, correct? And I have an 8 here, correct? I can't do a 2 and an 8. It has to be 2 and 2 or 3 and 3 or 4 and 4. You understand my point? Okay? Now, the next thing that we have to determine is, once I've determined that I can multiply those matrices, I have to, well, actually, you see an example here. Here's a 2 by 4, and here's another 2 by 4. You would think I should be able to multiply a 2 by 4 and a 2 by 4, but I can't because I have 4 columns in one and I have 2 rows in the other. I can't make a matrix work that way. Okay, so sometimes it'll say, hey, can you multiply matrix A by matrix B? And you wind up in the easy answer, the one that you're looking for, is no, you can't multiply these matrices because those two middle numbers don't match. So let's look here. Somebody give me the dimensions of a matrix. 6 by 3. Okay, somebody give me the dimensions of another matrix. 2 by 4. Can I multiply those two matrices? No. And this is the easiest way to put them. Like, don't put this as like 2 by 4 down here, because then I have to look at that, and that's going to confuse me. Okay? Does that make sense? All right. Give me the dimensions of a matrix, or give me the dimensions of a matrix, Axel. 2 by 2. Okay? Somebody give me the dimensions of a matrix that are not a 2 by 2 but will multiply by that. 2 by 12. Okay? Those matrices, those will multiply. Okay? Does that make sense so far? Easy? Okay. We'll erase that. Now, once I've determined that, hey, I've got a 2 by 2 and a 2 by 8, I can multiply those. Now I have to figure out what are the dimensions of the new matrix. Okay? So the product of two matrices is a matrix whose dimensions are determined by the outside numbers. So if I was here, I've got a 3 by 2 and a 2 by 2. Okay, look at their middle numbers. Are they the same? Okay, they're the same, so I can multiply them. But the dimensions of my new matrix are based upon the outside. The new matrix is going to be a 3 by 2. So inside determines yes or no. Outside, once the answer is yes, determines size, okay, dimension. Down here, I've got a 2 by 5 and a 5 by 3. So the new dimensions are going to be a 2 by 3. Okay? Have I gone past anybody? Because I'm guessing that matrices are something that's new to you. Have any of you worked with matrices up to this point? Nobody has. I didn't think so. All right, so somebody give me the dimensions of a matrix. Allison, give me the dimensions of a matrix. 2 by 4. Okay, somebody give me the dimensions of a matrix that's not a 2 by 4, but will multiply by that. 4 by 7. Okay, good. Okay, so can we multiply these two? Yes, the middle numbers are the same. What will be the dimensions of the new matrix? 2 by 7. Okay, we feel good about that? Okay, good. All right, and so if you ever get lost, granted that you've got these notes, but if the notes don't make sense to you, what can you go back and do? Listen to the video. Okay, watch the video. So when two matrices can be multiplied, the product is said to be defined. Okay, if we can't multiply two matrices, their multiplication would be undefined, meaning that we can't do it. It doesn't work. So the matrix that results, whenever we can define it, is what is called a product matrix. Product means multiplication, right? So nothing really too complicated there. All right, so, but actually multiplying two matrices is complicated. Okay, any element in a particular row and column of the product matrix is the sum of the product of the corresponding elements in, let's go ahead and elements in the corresponding row and column of the matrices being multiplied. Here we have a 2 by 2 and a 2 by 2, right? All right, so what are the dimensions of the new matrix? 2 by 2, okay? So if you look over here, A, B, C, D, E, F, G, H, I've got 1, 2, 3, 4. Okay, that works. So this is what I want you to see, is that I'm going to multiply A times E and add it to B times G. Okay? And that's this spot right here. So first, basically what we're saying is you're going to go by row position and column position. So first row, first column. Okay? First row, first column. The individual elements that make up first row, first column. I want to go slow through that so that you catch it. Okay? Now, I'm going to erase this. If I want to go to this next position, I need, this is first row, second column, right? Okay? So I'm going to go first row, second column. First row, second column. Okay, is going to give me this right here. Understand? Okay, we're going to do the whole thing. Okay? Now, what is this position? What is this position right here? No? Second row, first column. Second row, first column. So, second row, first column. Second row, first column. You get it? You getting it now? Okay. What is my last position? Second row, second column. All right, so second row is C. I'm sorry. Hold on. Did I make I might have a typo in there. Let me double check. I think I've typed in something wrong. Or they did.
It's supposed to be.
Yeah, hold on. Yeah, it should be second row. Hold on. Second row, though.
CF and then.
Yeah, it should be second row, second column, second row, second column. So that should be a C right there. But your book has it wrong. Okay, so we're going to fix it. Okay, that should be a C, F, D, H. And your book does get it wrong from time to time. Okay, that's why we're talking about it here, because if you tried to follow your book on that, you'd be really confused. Okay, because it was right up until that point. CF plus DH. Okay, now if you can keep that in your head, okay, this position is first row, first column. Okay, second row, first column. First row, second column. Second row, second column. All right, if you can remember how to do that, you're going to be able to do more than just a 2 by 2. Okay, because we're going to get 3 by 3s, 4 by 4s, all kinds of different things. Okay, so you have to remember where you're at. And the more there is, the more addition that you'll do. Okay, the more steps that there will take place. Now, eventually, what we'll work on is how can I use my calculator to solve these questions. Okay, and that's where you want to get to. Okay, but for today, you need to know this. So the row 1 element of matrix A are multiplied by the corresponding column 1 elements in matrix B. Then these products are added to find a corresponding element in a product matrix AB. Continue this pattern row by column to find all the elements in the product matrix. Hopefully we understood that. That's why I wanted to take it slow. The multiplication of real numbers is a commutative operation, okay? Because either number can be first or last, but this property does not generally hold for multiplication matrix unless you're dealing with two things that are exactly the same dimension, so like a 3 by 3 times a 3 by 3. Then you can switch, all right? But if you're doing a 2 by 4 and a 4 by 12, right, those things are not commutative. You can't flip them, okay? All right, a square matrix is a matrix with the same number of rows and columns, a 2 by 2, a 3 by 3, a 4 by 4, right? Okay, that's a square matrix. And a square matrix will have a main diagonal of elements, meaning that, you know, if I look at a 3 by 3, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, I have that diagonal right there. And that's what we call the main diagonal. It's the diagonal that goes from the upper left corner to the lower right corner is what is called our main diagonal. Okay, from top left to bottom right. A multiplicative identity matrix is called I. I show it there with a capital italicized I. Is a square matrix in which all the elements are 0 except the main diagonal. All of the elements in the main diagonal are 1s. This is another place where your book is wrong because it says all the elements in the main diagonal are 0. That's incorrect. All right, so a main diagonal of a 3 by 3, or what an identity matrix of 3 by 3 is going to look like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. And if I take any matrix times an identity matrix, I'm going to get the original matrix. Okay? That's the one where he first learns that he can dodge bullets. It's the original matrix. Only Eric laughs at my jokes. It's okay, though. All right. So an identity matrix of a 2 by 2 would be 1, 0, 0, 1, because there's my main diagonal. Okay? The product of any matrix A in the multiplicative identity matrix is going to be the original. Okay? Because, you know, it'll just will. Therefore, matrix A times the identity matrix equals the identity matrix times matrix A, or just A. And that's it. So let's look at some questions. Actually, nope, not that. We're at what, lesson 9? Okay, lesson 9. Time you guys out. Ooh, we don't have much time, do we? 10:36. Okay. All right. Some of these, this is simpler than it looks. Okay. If this matrix equals this matrix, then B equals what? We'll start off by finding out what A equals, right? 6 times what equals negative 18? Negative 3. So we know that A equals negative 3, right? And 10 equals A plus B. So 10 equals negative 3 plus B, right? You could add 3 to this side. B equals 13. Okay? That's a little frustrating because it's not necessarily something that's covered in this lesson. That type of question isn't, but do we understand that? Because the two things are equal, so the numbers, and because you'll notice negative 8 equals negative 8, 4 equals 4, so 10 has to equal this, 6 has to equal that. Yeah. Okay, let's look at the next question down, number 2. They don't talk a lot about showing it like this, but what they're saying is that matrix P has the dimensions of a 7 by 5 and matrix Q has the matrix of a 5 by 3. So can we multiply those two things? Yes, because 5s are in the middle. What are the new dimensions going to be? 7 by 3. So our answer is B. It would be defined. Okay, we're good there? Okay, great. Okay, number 3. Okay, for the matrix product, P equals these two things multiplied by each. Well, let's see, what are they looking for here? Okay, notice it says P1, 2. Let's see. So 1, 2, what is that in the matrix? We've got 2 by 2, 2 by 2, so we're going to get a 2 by 2, right? So that's what, first row, second column? All right, so that would be this position right here, right? So first row, second column. So first row, second column, correct? So negative 5 times negative 3, right? Plus what? 3 times negative 3. Okay, what's negative 5 times negative 3? 15 minus 9. What's that? What's 15 minus 9? Okay. Why? Okay. Oh, all they're looking for is that right there, though. Okay. Does that make sense? Yeah, find the expression. I'm sorry. But the answer is 6, by the way. Okay? All right, let's come down here. Find a product of AB if possible. Well, what are the dimensions of A? 3 by 2. And what about this one over here? 2 by 3. All right, so what are the new dimensions going to be? 3 by 3. We already know that it's not possible, right? We know that it's possible, but we also know that it's not B, correct? Okay, so let's look at this. This position, okay, first row, first column, right? Okay, so first row is 5 by 6, 8 and 2. So that's 5 times 8 plus 6 times 2, right? And we know that we're going to get 52 because 52 is the only answer there, right? So let's go to this guy right here, right? Because there's a difference. Rather than making you do all of them, okay, what am I actually doing here? The position is what? First row, second column, okay? So I need 5 times 0 plus 6 times 6. Well, what's 5 times 0? 0 plus 6 times 6. Has to be A. Okay, now, if this wasn't a multiple choice question, could you fill in all 9 of those positions? Okay? Okay? So, you know, if I want this spot here, that's first row, third column. So that's first row, third column. So we get our process here. If I'm going to close kind of with this. If I want this position, that's second row, first column. Okay? So we get some of the processes here. If I want this last one over here, third row, third column, third row, third column. All right, so negative 4 times negative 3 plus 0 times 4. Okay, leaving me with 12. Okay, if you can do that, you guys are golden. Okay? Is the questions not on there? Oh, okay. Well, I'm sorry. Let me put it on there, or I'll say it for you. Yes, always. It's the same thing. How are matrices, or how is multiplying matrices? Where in the real world would somebody need to multiply matrices? Okay, that's the essay. The essay question will be the same every time. How can this lesson be used in the real world? Does that make sense? So you don't ever have to ask. You'll always know. Okay? Now, if I ever assign 2 lessons, you just need to pick one of those lessons to do your essay over. Okay? You don't have to do it over both. Okay, all right, I'm going to stop there.